welcome to Arduino tutorial number 7, hosted by the real Tony Stark. In this tutorial, we'll be covering topics such as the for statement and the if statement. For this tutorial, you will require the following items: the Arduino software, an Arduino Uno, a breadboard, a potentiometer, a push button, and some resistors like 330 ohm and a 10K resistor, some jumper wires, and I will be using an RGB LED, but you may use 3 different colored LEDs, or 3 of the same color, or 1 of one color, or none at all. It's entirely up to you. We're going to be going through this just to demonstrate the for and the if. So, first things first, let's figure out how to wire this breadboard up. As I mentioned, I will be using an RGB LED. So currently, let me show you what I've got on my breadboard here. And what I've got on the screen is I'll be using as a guide for you as well. This is the SparkFun version 3 guide for the red board, which is the same as the Uno. And what it shows us how to do is how to hook up an RGB LED. Now, if you're not using that, it's not too important for you to know how to do this, but definitely the guide is going to help you to set up any wiring that you're doing with your LEDs. If you're unsure, especially with the push button as well, I believe that is tutorial number 5 in here. Yep, I think we jumped right over. There they are. So there's a push button. The push button I'm using is very similar to the one in the SparkFun Inventors Kit. It has 4 legs, and as you'll notice, 2 of them are side by side and 2 are on the other side. And that's important to note because the 2 that are side by side are, or can be, connected when you push down the push button. The 2 on the other side are also closed at that same moment. So if you want the circuit to read the push, you have to make sure that it's basically connecting on this same side of the button, and that will then close the circuit when you push it down. Okay. For the RGB LED, you essentially got 3 LEDs in one, red, green, and blue, and they have a common ground on this one anyways. Some of them have common positives. Ours have common, this one has common ground. So there are 3 330 ohm resistors on this side, one for each of the red, green, blue LED legs, and then this side is simply a little connector to go to our common ground over here. And then the potentiometer was used in the last tutorial. So, how do we wire this up? Well, as always, we can start with our red for our 5 volts. And we'll go right into the board. I like to do it down at the end there. Let's go with brown for ground, as I don't have black. And we'll make sure we get that one in the right spot here. Perfect. I'll plug that into the blue line. We're also going to need to connect our potentiometer to some positive voltage. So we'll plug that in there. And we got one of 3 legs. I'm going to put in that side. That looks pretty good. And we'll keep the common ground color going on here. And go over to the other outside leg of the potentiometer. And then we want to route this center one, which is the analog reading, into analog 0. Alright, potentiometer wired up, same as the last tutorial. The next step is this RGB LED. Now I've chosen specific colors so I can identify which pin on the Arduino is going to control which color of the LED. So I'm going to run red over to 9, and I'm going to run green is over here and goes over to 10, and blue, which is over here, goes all the way over to 11. Now, why did I choose 9, 10, 11? Well, if you remember from a previous tutorial, we talked about PWM pins, and those are the ones that have the little squiggle. It's pins 3, 5, 6, 9, 10, 11 on the Uno anyways. And those ones all have the ability to do pulse width modulation. So that's important for us if we want to fade the LED, which in this case I do want to do. So that's why we're going to make sure we hook up to those so we can get variations in as opposed to just on-off. And finally, our push button. And again, if you look at the diagram, the wonderful diagram in the SparkFun guide book, you'll see that there is a 10K ohm resistor between one of the legs of the button, and it doesn't matter which, you just pick a leg, okay, and that's going over to the positive, the 5 volts. Now, the term for this, when you do something like this, is called a pull-up resistor. What does that mean? Well, a pull-up resistor, right now it's connected to 5 volts. Essentially, it's this button is going to try to draw that 5 volts through this resistor, but 10K is a lot. So there's only a tiny trickle of that 5 volts approaching this button. So the other end of it, what we're going to do is we're going to hook up this leg. I guess I'll use white. That's good enough for the ground as well. So that's going to go to our ground, and then the yellow wire that I'm using is going to go in line with, in between this resistor and this leg of the button. Now, what is that? Why are we doing that? And let's choose a digital pin for this. I guess we'll go with digital pin 3. Oh, let's go 2. That works. Why do we do that? I mean, it should be a simpler setup, and there is. But what this allows us to do with a pull-up resistor is that when I press this button, it's closing the circuit. And there's a resistor on this side of it when it's connected to the positive, so it's preventing a lot of that voltage from coming through. But on this side, it's directly connected to our ground, so it's a much stronger pull. So what happens is this yellow wire, which is going to be our analog reading, or the digital reading pin, is going to detect a much stronger pull towards low when it's pressed. And since there's no low at all and a tiny bit of positive, it'll read high without putting a lot of strain on this pin. We don't want to run 5 volts into that pin. So we use a resistor to prevent any damage to the board, as well as minimize the amount of current draw you are using. So this is basically the setup that we're going to go with today. I know these wires kind of get in the way of seeing what we're doing, but hopefully the guidebook online can assist you. All right, let's get to the code portion now. Now that our circuit board is, I assume, set up correctly. So we'll start with the for statement. And for statements, as I've described before, are really about repeating a block of code multiple times when you know the set amount, or if your variable that you're going to use as the counter knows the set amount. So it's not an infinite, it's usually not an infinite situation. It's a situation where it's a defined number of looping times. Okay? And the syntax is listed on the Arduino website, but I'll go through it in more detail as we type up our code here. Okay, so as always, I'm going to define some variables at the beginning. Let's think about on our circuit, what do we need to define? Well, let's say const int. That's a constant integer number. Let's define our LED pins first. So we'll say LED red equals 9. Okay, and red pin, red LED pin. Okay, const int LED green equals 10, semicolon, green LED pin, const int LED blue equals 11, blue LED pin. Great. What else do we have to define on here? Well, we've got our const int pot pin, that's our potentiometer pin, is A0. And again, only when you're defining variables can you use integer as A0. So we're defining pins up here. Okay, that's where we'll allow that A0. It knows which pin we're talking about. A0 is potentiometer. Read pin. Okay, const int. Oops. What else we got? Button. So we'll say button pin equals 2. The button pin or read pin. Okay. Anything else? No. All right. Looks like we've defined our pins. Almost. Okay, we've got at least a variable name for them now. I guess we have to initialize them here. So we're going to say the first thing is pin mode, and we know that LED red is going to be output. Don't forget all caps there, and it'll turn blue when you've defined it properly. Pin mode, LED green, output. Pin mode, LED blue, output. Ooh, look at that pin mode. What else? Pin mode. Oh, I don't know what that's about. Okay. Hot pin, in this case, is an input. Pin mode. Button pin. Input. Okay, now keep in mind this is an analog input, and this one is a digital input, and that's because there's only two states for a push button, but there's again that 1024 states for an analog input, at least when we're using Arduino. Okay. Now, one other thing we learned in our last tutorial was the serial monitor. I'm going to define that right now because it's always serial.begin. We'll say 9600 again. We're going to be using that in pretty much every tutorial from here forwards. Initialize your serial monitor so we can start to detect what's going on in our code as we write it. Okay, or as we run it. Finally, anything else that we need to define here? No, I think we're good for now. Okay, so we've got some of these variables which are defining our pins. We've initialized which pins are inputs and outputs. That's great. However, we are going to need some variables here, which I guess we can initialize down in our void loop. Well, what do we want this thing to do? Well, the first thing I want this to do is I want it to fade my RGB LED just from off all the way to full brightness red. All right, so that's what we're going to do here. So again, watching previous tutorials, you will have seen this once. So if you need to refresh your memory, go back and watch those previous ones. But all we're doing here is let's create a variable, int, and let's call it red level. And we shall say, well, you know what? I'm going to define it up here. Int red level equals 0. Now, why did I do that? Because I want to define this outside of the entire code. Let's leave it up here and see what happens now when we make it, when we assign it something down here. So what do we want to assign it? Well, we want to go from 0 to 255. Okay, but last time we did that by setting it up to mapping it to the position of the potentiometer, and there was just we just want this to do it on its own. So this is where the for statement comes in. So we have a variable for it now, which is red level. And what we're going to say is for, and then a round bracket. And then int, we're going to initialize a variable. This will be the counter for this for statement. So let's say I. I is very commonly used for for statements. I, J, K are the first go-to variables for these. Just standard practice. And we'll start it at 0. All right. Now, important note here. We put a semicolon inside this for statement. It's one of the rare occasions where there's not a comma separating as there are up here inside the brackets. This is an actual semicolon. You have to do 3 different statements in here, and 2 of them have to be ended with a semicolon. So the first one is defining the variable, the counter for this for. The next one is saying, okay, what is a condition for this? So when do we want it to stop counting? Well, in this case, we know that the analog output range of the PWM pin is from 0 to 255. So we're going to say I, so when I, as long as I is less than 255, then run the code that's in here. Okay, that's what this is saying here. So as long as I is less than 255, run whatever's in here. If it's equal to or greater than 255, then it's going to finish this for statement. So that's our thing, and we need a semicolon after it. Okay, and there's always going to be some sort of conditional operator here. I is greater than or greater than or equal to. I'm just going to leave it at less than 255 for this one. And then the last one is we're going to say I equals I plus 1. Now don't get all crazy, some of you out there who know this code and are like, wait a minute, that's the slowest way to do it. I'm aware. So the reason why I wrote it this way is because what this part does is it tells it how to count each time it goes through this. So I starts at 0. It's going to say, wait, is I less than 255? Yeah. Okay. Then I want you to add 1 to I, then run the code and come back up. So next time I is going to be 1. Still less than 255? Yep. Now we're going to add 1 to it and make it 2. However, there is multiple ways to write this same statement. Okay, I'm going to write it down here for your own comparison. You can say I equals I plus 1. You could say I plus equals 1. Okay, that will give you the same result. And you can also say, which I use most often, I plus plus. So the only situation where I would use one of these that isn't I plus plus, this is the one I'll use most often, is where you want it to count by a different amount than 1. Okay, so I plus plus just means increase by 1. Increase this variable by 1. The alternative is I minus minus, and that would subtract I by 1 each time. So it's entirely up to you, whatever makes the most sense, but I++ does work here and saves a lot of space, and it's quicker to type. So I'm going to use that here, I++. All right, we have our for statement essentially set up. The only thing we need now is a closing brace and the code inside for what it's supposed to do when it runs each part of the loop. Okay, so what do we want this to do? Well, we want it to turn on that LED. So we're going to say LED red. We're going to say analog right. Or LED red. And what value do we want to run LED red at? Well, that is the interesting part of the for statement, because we know that each time it goes through this loop, I is going to be bigger and bigger, and it's going to approach 255. So we don't want to tell it to be 255 in here, because that's just going to make it 255 every time it goes through. So if you figured it out, we're going to make it equal to I. Okay, and you could use that red level variable that I've made up here, but in this instance we don't need to yet. So we're just going to make it work like this. Analog right, LED red is I. So first time through, it's going to be 0. That's what I value will be. So it's going to write 0 to that pin and it won't turn on. And then you're going to go all the way up to 255 until it's fully bright. Now, let's upload it and see what happens. See what we get, what kind of result happens here. Let's upload. Okay, compiling sketch, no problems, no orange. That's always a good sign. And let's see. All right, so this is interesting because we've uploaded it, but look what it's doing. It's going really rapidly, and again, it's repeating because it's in our loop. But it is giving the effect that we want. It's fading from 0 to on, but we didn't define how long it should spend at each increment of this count. Okay, so we're going to say instead delay. We're going to add that in. And we'll say 10 milliseconds each time at each level of this increase. So let's upload that and see what the difference is. Much more gradual. So this is where you can create some lighting effects, especially in my stuff like my repulsors. This is exactly how you do it. You can fade, and with one little tiny block of code, you don't have to write each state of it. You don't have to have an analog sensor telling you what to do. It's literally just a fade from whatever values you want. Okay, so that's essentially it for a for statement. I'm going to try and do this again for you, except we're going to start it at 255. So we're going to fade from on to off. So let's go is greater than 0. And instead of I plus plus, we're going to say I minus minus. Still going to delay 10 milliseconds, sure. And we still want to write, let's make it green this time. So see how easy it is to change your pin as soon as you've named it, okay? Great, let's upload and see what happens. So we're going to start at the top. We're going to go until it gets down to 0, and then we're going to subtract 1 each time. And there you go. So we see we get full blast and fade off. Okay, cool. All right, I'm going to block out this code so we can try something a little different here, a little more complicated. What if we wanted to fade between the 3 colors, actually? Let's keep this block of code. And let's say we wanted to fade between the 3 colors. And what I mean by that is, let's fade red from off to on, then green from off to on, then blue from off to on. Okay, well, the nice thing is we can use the same piece of code here. And let's go is less than 255 I plus plus, and we'll start with red. Okay, now again, what I want to do is I want to fade the red from off to on. Then after that, I want to fade the green from off to on. So I'm going to copy and I'm going to paste. Okay, and we're going to change that red to some green. And then we're going to paste it again. And we're going to go for some blue. Okay, now, can you predict what's going to happen here? Let's see. Let's see if you know what's going to happen. All right, let's give it an upload and let's find out if you were right. Here it comes. Fade to red. Oh, that's weird. Oh, we got some green, and now we're kind of getting into, oh, that's almost white, and now it's purple. That isn't really what we wanted. So what exactly happened here? Well, let's go through and see. We faded the red LED from 0 to 255. We got all the way up to 255, and then we went down here. It ended this part, and said, okay, let's go to the next part. And now it starts increasing the green while the red is maxed out. Well, if you know anything about making colors from light, combining red and green gets you a yellow. So I'm going to reboot the thing here, and you will see it's actually a little bit of a greenish yellow, but there goes the red, and then we get into a yellow. And that's because the red is maxed, and then we're getting a max green, and then we're getting max 3, and now it's reversing. And so what we need to do after it ends this part is we want to set analog right LED red 0. Okay, we're going to, after each of these, make sure LED green 0. And I'm just going to copy that, paste it down here, make it blue, and let's upload now. So now we should see each one going independently every time it loops through. There's the red, there's the green, and there's the blue. Ooh, beautiful. Okay, so this is a lot more code than we need. And what you'll see here is that the reason why we use a for statement is so we can eliminate the need for repetitive code. Okay, and we have something that's very repetitive here. Is there an easier way to do it? Yes. Okay. I'm going to move this down What we're going to do is we're going to use an embedded for statement. So it's going to be a for statement inside a for statement. Oh my goodness, we're going crazy this time. All right, so for int, how many times do we want to do this? 1, 2, 3. But don't forget when we're counting. So int, we'll call this one j, I guess, outside. That's fine. J equals 0, and j is going to go less than or equal to 2. Now, why is that? Because if j is 0, do it. If j is 1, do it. And if j is 2, do it. That's 3 separate times. So even though we want it to go 3, you want to specify to make sure you get enough counts. Okay, so remember that 0 is one of them. And then we go j plus plus. Okay, great. Now we're going to take this block of code. This is the part we want to repeat. Oh, and this, I suppose. We're going to indent it so we can separate it. And I'm going to remove this stuff. We're not going to use that anymore. Okay. So we know this is the stuff that we want to repeat. However, all it's going to do is we're going to see the red repeated every time. Well, that doesn't really accomplish what we want here. We're kind of missing something important, and that's the distinction of, okay, what do I do when j is not 0? All right, so that's what we want to have is a different case, and we're going to use an if statement for that. Okay, so we're going to say if. Actually, I lied to you. We're going to do it inside of here. So I'm going to get rid of this empty space. For, great. Inside of here, we're going to say if j is equal to, double equal sign, okay, when we do inside an if statement, 0, open bracket. All right. And we're going to go, whoop, and we're going to back it up. Okay, so j is 0, do with the red. Great. However, else if j equals 1, open curly brace, and we're going to do this. And actually, I'm going to remove this delay because we don't need to repeat the delay every time. The delay can come regardless of what happens in the if statement. The delay will come down here. So that's fine. We can leave that there. However, we are going to repeat this here. And we'll go again down here. You say else. Now you could say else if j equals 2. However, this is the only other condition that could happen here. So we're just going to say else. Open curly brace. Yep. And then down here we will paste the same code. And obviously we're going to change this one to green. And we're going to change this one to blue. And we're going to go to the end of this and make sure we close off our if statement with a closing bracket. Okay. So this is all part of the if statement. This delay comes after, because regardless of what color we're doing, we still want it to delay 10 milliseconds. Great. And then it will end this for statement of the fading whichever LED it wants to fade. Okay. And then we want to make sure that we turn off whichever LED it was that just went. Now, in this case, we don't know which LED it was that just went, and we could put another if statement. If j was 0, turn off the red. But you know what? We can turn off all of them at the same time because it doesn't really matter. We're resetting them all in this instance anyways. So we're going to paste this 3 times. We're going to say the same for green and the same for blue. When it gets to the end of this part right here, you'll see this is the end of this for statement. So at the end of each time it runs through this, it will turn them all off and it will go again. It's going to increase this to 1. Now it's going to go through and say, oh, it's 1. We'll do it to green, fade it all the way up, and then it will go all the way back. Increase this to 2, and hopefully do it with blue. So let's find out. Let's find out what happens. Let's see. Fading to red, fading to green, fading to blue, and fading to red. Beautiful. So same effect, except now we use an if statement inside a nested for statement. A for within a for. And again, this just comes with practice in terms of condensing your code to make it as efficient as possible. So we can use as many for statements within as many for statements to repeat blocks of code over and over again to generate some really cool stuff. And what we did was we referenced J inside of I, and there's a whole bunch of neat things that you just did all at once to make this effect. Okay, so the only other thing that I wanted to really introduce today was with the if statements. And the push button. Okay, I have the potentiometer there, and you could your challenge for the end of this is to use a potentiometer to fade from the red, so you get the same effect that's going on with the LED right now, but to happen when you turn the potentiometer from one end to the other. It should fade all the way to red and then turn off, all the way to green, turn off, and all the way to blue, turn off. That's your challenge. My other instruction point is for this push button. So for an if statement, so far all we've had in there is one condition. Okay, we haven't compared multiple conditions, and if statements, a lot of them we will have to do that. So right now this is all great, okay, that this works, but what if we say we only wanted to do this looping thing if the button is pushed in? How do we do that? Okay, so let's say if well, what's our button state? We don't even know. So let's generate a new variable, int button state, or even better, let's make it a Boolean because there's only two options for this. Int or Boolean button state equals digital read button pin. Okay, so that's going to get the state of the button. After that, we want to go serial. We want to see what this is doing. Print, and we're going to say button. Very good. Serial print line, and we want to print button state. Okay. So what this is going to do is going to read the button state at that moment for this run through. It's going to print button, and then next to it, it will print the button state. And by printing line, we jump down a line each time. Now, if button state equals true, okay, so, sorry, it was true. Essentially, we're saying if the button is not pushed in, what do we want it to do? Nothing, okay? Now, so in that case, we want to ask if it's false. That means that we've pushed it in and it's being pulled low or to ground, okay? So let's go with, let's indent this whole thing, and we'll add another curly brace for our new if statement. And that's all we're saying is that if the button state is false, then run this. We don't even need to put the else because there is nothing else. If this is not true, it won't do any of the stuff inside of it, and we will have nothing happening. Hopefully. Let's upload and see what happens. The moment of truth. Nothing is happening. Let's click on our serial monitor and find out why. Hey, button 1. There you are. Okay, now it is button and it is 1 because we are not pushing in. If I push it in, we now have 0. Button is 0, and look, it is fading from red to green to blue. It is doing that block of code. If I let go of the button, it keeps going. Why? Ah, there it goes. So what was interesting there is I let go during the fade, okay, during this sequence. And what that meant is it didn't actually check the button state again until it finished doing this whole set of things. And because we have that delay in there, it's quite a bit of time goes by before it goes to check the next thing. If I was still holding it in, it's going to run it again until I'm let go and it comes back to this point and I'm no longer holding it here. Okay. Now, if you wanted to get a little more creative, as I said with these if statements, there are operators that you can put in between statements. For example, if I wanted to say and, okay, and if we wanted to talk about another variable here that was something like int hot val equals analog read hot pin. Okay, so again, this is going to be now the value of the potentiometer. And we could say if button state is false, so that means if it's pushed in and, okay, we have to have two of those ampersand signs, and pot val is greater than, well, remember it ranges from 0 to 1024, so let's say it's greater than 512, Okay, then do this. So now there's two conditions here that both have to be proven true. Okay, even though we're asking for this one to be false, they both have to be correct in order for any of this to happen. So we can have, and let's upload this one, and then we'll talk about the other variations you could put in there. So I'm not sure what position this potentiometer is at right now, but again, when this starts, nothing happens. When I push the button, it's going. So let's figure out why if I turn this. Aha! So something isn't working here, and well, it's not. It is working, but we can't really see what's working. We forgot to do one more thing. We want to do another print so we can monitor the value of our potentiometer. So serial.print is this. We'll do a comma space and don't forget the quotation marks. Serial.print line and pot val. Great. Now if we upload it, we can now monitor the state of both of our input devices. And we'll go, okay, so the pot value is currently, if I dial it, okay, down to 0. So if I hold the button, you'll see it goes to 0, and I can still change this pot value. But as soon as this pot value is going to get up over 512, now we get the fading happening. And each time it's going to go and check through. Now if I let go of the button, when it finishes that blue, it'll read it as 1, and even though the pot value is above, it doesn't give the effect. It's not until both are true that it will do that. Now, as I said, there are many alternatives you can put in here instead of and. Okay, this is the other alternative. It's a weird bar above the backslash on your keyboard, straight up and down. Okay, and what we're looking at there is or. So this double vertical line means or. So in this case, let's upload and see what happens. You may already be able to predict what will occur. Maybe bring up the values here. Okay, now I'm not holding the button down, but it started activating. So I'm going to crank that potentiometer down. All right, so there's that pot down there. Great. And if I push the button, oh, it starts fading. Now the pot is below that 512. Doesn't matter. Either condition will trigger this because we said or this or this. If either one is true or either one is correct, then run it. You can do other things like not. Okay. So if this is true but not this, so this would be the opposite. And I don't use this one very often. If you do not this, then you would be able to say that one condition is true, the other one is not. I would just write that, okay, as this. Okay, I would do and it's less than 512. That's the not greater than 512. All right, so there are some situations where the not makes sense, but for most of the time, I'm using either and or. And you can do this in conjunction. Okay, so you could say, if this and this are true, put them in brackets to make sure that they are a collective statement, or something else. Okay, so some other condition. So if these are both true, or this something condition is, then do this. So there's a lot of creative ways that you can use this to create logic. Okay, in your code, but that's basically it. As I said, use the potentiometer now. You saw I've kind of set it up here. See if you can figure out how to get the same fading effect at your own control, not using the for statements, and see if you can do that with very conservative code. If you have any issues, please post in the comments below. And next time we will be covering things like, what haven't we done yet? While, maybe a little bit of while and some do while, and a little bit of switch case. Wonderful. And after that, we're getting our own functions. All right. So thanks for tuning in today. Hope you got something out of this one. And as always, thanks for watching. This is The Real Tony Stark, signing out.